Okay, so in this example here, we're going to be talking about how to find the equation of a quadratic in vertex form based on the information that we're provided here. So let's go ahead and read the problem, and then I'll talk about how we're going to set up this problem. It says a quadratic passes through the point 1, 4 and has a vertex at 2, 2. Find the equation of the quadratic in vertex form. So before you can do this problem, you have to know how to write a quadratic in vertex form. And that's going to be the following. You have y is equal to a, and then x minus h squared plus k. So when we look at y in x here, so y in x, that's representing any point on that parabola, okay? So x and y can be any point on that parabola. Then looking at h and k, that is very specific. That is talking about the vertex of your quadratic. So h is the x value of your vertex, and k will be the y value of your vertex. And this a out in front is going to be a vertical stretch or a vertical compression depending on its value, meaning it is going to be making this quadratic either skinnier or wider, again, depending on the value of a here. That represents a vertical stretch or a vertical compression. So at first glance, you may be looking at the problem and may be saying, well, I have a point right here. This would be x and y. And then I have my vertex, h and k. I can go ahead and put this right in vertex form, and then I'd be done. The only issue with that, you cannot assume that your a value here is going to be 1. We don't know what a is going to be. So what you have to do in this problem here is you actually have to solve for a, and then you can go ahead and put it all together. So for example, I have a point 1, 4. That means my y value has to be 4. I don't know my a value. I'm going to solve for it. My x value is going to be 1. My h is 2. So when I plug it in, I get negative 2 and then squared. And then my k is also 2, so plus 2. And now from here, you're going to go ahead and simplify this down right here. So we get 4 is equal to a. 1 minus 2 is negative 1. And then squared, and then plus 2. We know that negative 1 squared will be 1, so I get 1a here. So 4 is equal to 1a or a, and then plus 2. And then finally, minus 2, you get a is equal to 2. And so putting it all together, you're going to have the following. You get y is equal to, here's my a, I get 2, and then I have x, my h is 2, so minus 2 squared, and then my k is 2, plus 2, and here we go, we are done, right? There's the quadratic in vertex form, okay? Let's go ahead and try another problem. This one will be slightly different. So here's our next example. In this one, we're actually provided with the x-intercepts, or in other words, the zeros. And it's telling us that a quadratic has x-intercepts at negative 4, 0 and negative 2, 0. It says find the equation of the quadratic if the vertex is negative 3, 5. So again, these x-intercepts are representing any point on that quadratic. So for example, this is x, this is y, this is x, this is y. And then again, my vertex is very specific. I want to call that h and k. So h and k. So again, writing out the formula of a quadratic in vertex form, we have y equals, and then a, x minus h squared, and then plus k. So we're going to do the same thing here, except in this problem here, it doesn't matter what point you pick. I could pick either one of these intercepts here. It won't matter. I'm going to go ahead and pick this one here. You could pick the other one. It doesn't matter. But for my y value, I'm going to plug in 0. A, I don't know what that is. I'm going to put a here. My x is going to be negative 2. My h is going to be a negative 3. So when I plug it in, it becomes a positive 3 because I already have a negative here, right? So 2 negatives make a positive. It gets plugged in as positive 3 and then squared. And then my k is plus 5. Now simplifying down this part here, we get 0 is equal to a, and then we get 1 squared plus 5. And so we know that 1 squared is 1. So we get 0 is equal to a, or 1a, plus 5. And then finally, solving for a, you're going to get a is equal to negative 5. So putting it all together, we get the following. We get y is equal to my a, negative 5, and then x, my h is a negative 3. When I plug it in, it becomes positive 3 squared, and then my k is 5. And here it is. Here is the equation of the quadratic in vertex form. All right. So that's it. That's how you find the equation of a quadratic in vertex form. Just remember, you cannot assume that your a value is going to be 1. You have to go ahead and solve for it. And again, that a value is representing a vertical stretch or compression, or in other words, that is going to dictate how skinny the graph is or how wide the graph is, depending on that a value. Okay, so I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.